So now we have seen what a sequence is. A sequence is basically just a list of numbers. A sequence is just a list of numbers. So we typically write out these numbers as just A1, A2, A3, and so on. So now our next big topic is going to be about a series. A series is technically just the sum of all the numbers from a sequence. So technically a series is just the next step from a sequence. When we have a sequence, we only have a numbers. But when we talk about a series, we basically add all those numbers together. Now, before we talk about how to find the sum of all these numbers, let me actually talk about this notation first. The sum notation will have several components. Let me talk about them. The first thing that you see behind the sum, this is called the terms. This is the terms. It is going to be the numbers that we're going to be adding up. Below the summation notation, we see n equal to 3 here. This n is our variable. So this n is variable. The number 3 here, this is the starting value. This is the starting value. And the numbers up top, the number 7 here, this is going to be our final value. So this is our final value. So let's say, what is this then? The sum of 2n plus 5 when n go from 3 to 7. So this is going to equal to the sum of several things where my variable will start from 3 and go all the way to 7. So if I were to write this down, it's going to be the sum of several things, where in each thing, the value of my n is going to be, let's see, my n is going to start off being 3. So my n is going to start from the starting value, and it's going to keep going up by 1 to the final value. So n equal to 3, equal to 4, equal to 5, equal to 6, and equal to 7. Now, for each value of n, I'm going to compute the terms in behind the sum now. So when n is 3, my term is going to be 2 times 3 plus 5. 2 times 3 plus 5. When n is equal to 4, my term is going to be 2 times 4 plus 5. When n is equal to 5, my term is going to be 2 times 5 plus 5. And 2 times 6 plus 5. And 2 times 7 plus 5. So here, this is basically just what the summation notation means. Now, if I were to add up all these numbers, so let's do the math real quick. This is going to be just, let's see, 11 plus 13 plus 15 plus 17 plus 19. And these all add up to 75. So this is how we compute the value of a summation. So let's try to do this again. So now then, my term is going to be 2 to the I plus n. My term is 2 to the I plus n. My variable is going to be I. My starting value is going to be 1, and my final value is going to be 4. So then here, I'm going to have a bunch of numbers being added up. Because my I is a variable, so the terms that we're going to add up is going to start from I equal to 1. So my I is going to start being 1, and then 2, and then 3, and my final value is going to be 4 here. So now, what is the value that we are going to add up here then? The value that we're going to add up is going to be 2 to the I plus n. So when I equal to 1, my numbers, the term that I'm going to add up, is now going to be 2 to the 1 plus n. Notice how the value that we have down here, because I is my variable, so when I equal to 1, my term here is going to be just 2 to the 1 plus n. I don't have n being a variable here, so my n is just going to stay there like that. When I is equal to 2, I'm going to have, let's see, 2 to the 2 plus n, and then 2 to the 3 plus n, and then 2 to the 4 plus n. Notice how, well, because in the previous example, my n is a variable, so the value of n changed. The value of n runs from 3 to 7, but in the example B down here, my I is a variable, but n is nothing. My n is not any of the variable that we see here, so the value of n doesn't change. The value of n just stay like that, but the value of I is the one that changed from 1 to 4. Now, if I were to add this up, this is gonna equal to, let me see, I'm gonna have 2 plus n plus 4 plus n, and then 8 plus n, and then 16 plus n. So these 4 terms, they'll add up to, let's see, 30 plus n. 30 plus 4n. And for the next example, I'd like to write the sum that we have down here as an infinite sum. So, notice how in the summation notation it will follow the same scheme that we have above. So in the first example, the thing that I would like to sum is log of n over n squared, and my variable is going to be n. My n is going to start from 1 and it's going to go all the way to infinity. So if I were to write this out, this is going to be the sum of a bunch of numbers. It's actually going to be just a sum of infinitely many numbers, but let me just write a few first term here. So my variable is going to be n, and it's going to start at n equal to 1, to 2, and then 3, and then 4, and then 5, and so on. So when n is equal to 1, the terms in my sum, so I plug in n to be 1, so this is going to equal to just log of 1 over 1 squared. When n is 2, my number is going to be just the log of 2 over 2 squared. When n is 3, this is going to be just log of 3 over 3 squared. And then I'm going to have log of 4 over 4 squared. And then log of 5 over 5 squared. Okay, and so on. So these are the pink numbers are going to be the numbers that we're going to be adding up when we try to compute the value of this summation. Now let's do the last one here real quick. So here the terms that I'm going to be adding up is 1 over 2 to the n, and my n is going to start from 0. So let me now just write what these are going to be. So this is going to be, let's see, when my n is 0, I'm going to get 1 over 2 to the 0 plus 1 over 2 to the 1 plus 1 over 2 to the 2 plus 1 over 2 to the 3 plus 1 over 2 to the 4. And so on. So here I have written my this summation as an infinite sum. So the big question that we're going to be trying to answer now is, how do we find the value of this infinite summation? And we're going to spend several examples and devote the entire next lecture to answer this question.